Hi, in this lecture we will understand the problem of rotten oranges. So as you can see, this is a 2D array and the number which is representing as 2, like shown here, it represents that the oranges at these places are rotten, and the places which represent 1, that is these cells with value of 1, represent that they are oranges but they are not rotten. So the idea behind is that 1 represents oranges, 2 represents rotten oranges, and 0 represents empty cell. We need to traverse all the path in 4 directions, that is up, down, left and right, and in unit time the rotten oranges will rot other oranges which are just the neighbor of that orange that place. For example, if 2 is at this place, then it will rot all the oranges in the 4 directions which are at unit distance from it. Like if I talk about this 2, then it will rot this 2 and this 2, because these two were the neighbors in a unit time, and in the second unit of time this 2 and this 2 will be rotten by either by these, or you can say either by this. Similarly, if I go with this, it will rot this 2, this, not this, in 4 directions only, so this and this, so up, down, left, right. And in the second unit of time, this 2 will rot these all 3 oranges like this, this and this in 4 directions, that is up, down, left, right. So as you can see, 2 units of time were required here and 2 units of time were required here, so altogether 2 units of time was the answer. So in a unit time, it can rot the oranges in 4 directions which are immediate neighbor of that 2, so somewhat like that. So we are given these oranges. We will go with the algorithm of breadth first search, in which we will take a queue and we will store all the oranges in with representing their indexes of x and y in a cell. So for that I will create a class which will store the position of that rotten oranges. So I will create a class, let's name it as cell, and it will have x and y coordinate representing with an integer, and let me create a constructor which will receive int x and int y in perimeter, and I will pass this dot x to x and this dot y to y. So this is what we will do with the cell. Now coming back to this oranges part, I will iterate this for x till the length and y till the depth. For that I will store int x as n, so n will be oranges dot length, so it will store the number of rows, and m will store the number of columns. So oranges at 0th index dot length. So we have this n and m, so I will iterate int I equals 0, I less than n, I plus plus, and I will store int j equals 0, j less than m, j plus plus. And if any of the cell comes out with value of 2, that is oranges at I and j comes out to be 2, then I will simply store that in a queue. For that I will create a queue here, and x and y coordinates of that particular cell can be represented with cell class which we have just created, this cell class, and it will be q equals new linked list. We are going with the linked list implementation of q, and if any of the oranges comes out to be 2, I will just store q dot add that particular cell, new cell. Inside this I will pass x and y coordinate, that is I and j coordinate. That's it. So till now what we have done, we have stored all the oranges with unit time. After that I will apply a break that in unit time, if it has stored all the 2, then in the second unit of time it will store the other cells which are neighboring of the current rotten oranges. So what I mean to say, in the unit time, if I rotten these two oranges, then these two will not come in the same unit of time. These two will come in this next phase, that is next unit of time. For that, I will go, let me pass one here also, as I have done here. So what I will do, I'll apply a break by passing a new cell which will have the value of -1 and -1. This will be a kind of break for me. And after all passing all the cells and doing certain computation, that is rot all, and in that I will try to get the rotten oranges data in terms of time. I'll pass q here and also the oranges in that particular rot all oranges method. And after passing all oranges in that method, I will check whether all the oranges have been rotten or not. So I'll again check this method and call this here, and if any of the oranges comes out to be 1, then I will simply provide a boolean variable, or here only I can pass and print that all oranges has not been rotten. So for that I can do like sys out here only all oranges cannot be rotten. Why this cannot be rotten? Suppose if any of the cell comes out to be like here, if 1 came, and here if it comes out to be 0, and here comes out to be 0, then no such neighbor of this 1 is having any rotten oranges or oranges. So this cell with 1 as a value will remain as it is, so this cell will not be rotten. So in that scenario, we need to apply a check to check whether all the cells have been rotten or not with the oranges. So if this comes out to be rotten, then simply just after that return, else we can print time taken, and I can pass the time taken here only like count, somewhat like that, and I can store the count in a variable here only, and can pass this count here. So in this way we can store the count of variables which represents the time, and I'll try to calculate the count of this rotten oranges in terms of unit time. So we have this method now in which we are calling this queue. For calling this queue, I need to check the cell. For that I will go with the while loop. While this queue dot is empty, not is empty, and this queue comes out that it is not empty, then for a particular span of time I will need to maintain a flag. That is, if this is rotting these cells and meanwhile this is also rotting these cells, so both of them are rotting in the same span of time, and if they have rotten all the oranges in the same span of time, then I will just insert this new cell as a barrier or as a break, and after this break only again I will compute one more extra time. If it has rotten these two, then in the next span of time this two will rot these two. So somewhat like that only. So like that only I will maintain a boolean flag. I will maintain flag equals false. So here I will go first that if, or I can check here only if not, you can say kind of barrier, this current cell of this q dot peak, then go inside this. Otherwise, after computing everything, just remove that barrier. So I will do q dot remove, and again I will check if this cell, this q is not empty, is empty, then I will simply insert a new barrier inside this q dot add, and I'll insert new, then I'll add cell. Inside this I'll just pass -1 and -1. That is -1. So it will add, it will go for the next iteration inside this only. So after that I will just simply not return, but it will be void only, so computation will work in this way only. So I will go inside this barrier and create a barrier. What this barrier is, to check whether the cell is having value of -1 and -1. So I'll go with peak dot x equal to -1, and then peak dot y equal to -1. That's it. So it will be check whether it's a kind of barrier cell or not, like we have provided here. We have added a new barrier cell after all the data of Q2 has been inserted in it. Similarly, after all the Q data has been inserted inside this, then for that particular span of time we will insert a barrier. So we are maintaining a flag for that particular span of time. So we will go inside this. I will get the cell equals q dot peak dot poll to get that cell, and we will get a count of that cell, that if cell dot x cell dot y is a valid cell or not, that if it is coming out of the index or not, if is valid. So to check that, we also need the rows and columns data. For that we will go with oranges, and we will try to get whether this is valid or not. For that I will simply check here only, we remove this commented part, that if x is greater than -1 and then y is greater than -1 and x is less than oranges dot length and then y is less than oranges at rows column length, that is 100.0 length. So it will be a valid cell, and this orange cell with cell dot x and cell dot y is having value of 1, then I will simply change this value to 2. So this value will be changed to 2 and it will be inserted inside the queue. So for that, q dot add new cell, and I'll pass the value here, not this value but this value, cell x and cell y. So it would be new cell, and in the place of count I'll just pass this value. So the thing is, we also need to check the flag. For checking the flag, I will check if not flag, that it is happening in that span of time first time, so I will maintain that flag as true for that span of time, and for checking that span of time I need to increment that count. So we need to check this count and increment it for that span of time only once. For that only we are maintaining flag here. And also let me copy and paste it 4 times for 4 directions. And now the thing is, since we need to go to the top, bottom, left, right, so let me go first to the right. So x plus 1, here also x plus 1, and in the bottom 2 sides also x plus 1, and here it was x plus 1 only, and here also x plus 1. That is, first we will move in the right direction. See, all the cell data having value of 2 has been inserted in the queue here, and we are polling each queue data here and checking whether its neighbor is having, that is in the top cell of that particular cell, is having value of 1 or not. If it is having that value, then we are just changing it to 2, and also we are maintaining a count of that span with a flag that at this span of time only, if the time has not been incremented, then we are maintaining flag as 2 and incrementing that count for that span of time. And also, since this in the next span of time this cell will also be made as 2, we are putting that in the queue only. And for barrier, that for this span of time only, it should not change all the values. So in the end, we are just adding a new barrier cell. For barrier cell, we have provided this value -1 and -1. So this is happening like that only. So for y also, let me add 1, since I need to go in the all 4 directions, and also here also +1 +1, and need to go in the minus x direction also in the next span of time, and here also x -1, and here also, here it was x -1. I went little far and remove this part, and in this part. So now as you can see, what we have done, initially we calculated the length and number of columns, and we maintained a queue, and all the rows and columns data, or all cell data which was having a value of 2, we have inserted in the queue. And after inserting all the queue, for that span of time we have inserted a barrier, that we need to check whether this is lying in that particular barrier or not. If that is lying in that barrier, we are maintaining a count of that. So we went to check rot all oranges method. Inside this, until unless our queue is empty, we are going in the loop, and we have checked that this was a barrier or not. If this is not a barrier, then we are moving inside, and this is happening for the first time in that barrier, then we are incrementing that count, that is a time unit, and adding all the cells with the value of 2 whose value is having 1 in that span of time. So, and if that span of time is not there, then this is the next span of time, then barrier will not let us go inside this if cell. It will come out, and we will remove that barrier cell and check whether the queue is empty or not. So if comes out that queue is having lots of data, then we will just insert one more barrier cell inside it, and then again the next pop of this cell will happen if that is not a barrier cell, and somewhat like that will happen, and we will increment the count, that is the time unit of that particular cell. We have maintained a barrier cell by checking that x is -1 and y is -1, and we are checking whether this cell is valid or not. This is not lying in the array index out of bounds. For that only we have maintained this, and after that we are checking whether all the oranges whether they have been rotten or not. That is, only 0 or 2 should be coming. If 1 is coming, then it has been left behind. So we are just writing all oranges cannot be rotten. Otherwise, we are just providing the time taken count. So if I run this, I run as Java application, it is not terminating while queue is empty. If while this is not a barrier, then just go and empty all the data, and after all the empty data has been removed, then the barrier should be removed like here, and if it is not empty, then just add the barrier. So now when I run this, it will say the time taken as 0. Why this says the time taken as 0? Let me copy this and put it here. When I run this application, time taken as 2. So the thing is, these three sides will be rotten in one unit, and these 3 sides will be rotten in the next unit. Similarly, these 2 and these 2 will rotten in 1 unit. So here it is taking 1 extra time, that is 2 unit of time. So that's why 2 unit of time. Now let's check if I put 1 here and surround it with 0, so that all oranges will not be rotten, then it should not give the time, then it should give me a warning that all the oranges will not be rotten. Like this, all oranges will not be rotten because it has a one orange left with value as 1. So this was about the rotten oranges problem. Thank you all for watching the video.